DHCP server using the firewall's DHCP server, which you wouldn't normally do, I guess, but it's worth knowing how to do that. So we're going to set that up. Then we're going to set up the DNS relay using the firewall as a DNS relay, allowing the host to make the DNS calls against the firewall and that doing the lookups. So that's more security there because you're not now got hosts going off and getting their own DNS. And so that's what we're going to do. So that's the first thing we're going to do. Then we're going to look into NTP and the options that we have with DHCP and so on, just as a bit of a sort of a services type module. Okay, so what we've got first here is our topology as we know it. So we're on this PC here, and we're using this Palo and going out this way. Now we have got an ASA there as well, which we're going to look at for IPsec, but for now we're going to concentrate just on the services. So if I can get this to work. Okay, so log into our box. Took it quite an inordinate amount of time, some unknown reason. Okay, so we have here our Windows 10 box, which is actually our Frank Castle box, which we're going to be using, again taken from Mr. Heath Adams. When I did his course, I just haven't got rid of these boxes as yet. They will be changing soon, obviously, because you can see the license is about to expire. So currently we have no IP address. It's got a PIPA address, automatic private IP addressing, which, as you know, Windows does, so that it can communicate on its local segment with other Windows boxes. But there's no configuration, IP configuration. Okay, so the first place we have to go when we look here is to the interface itself. Now our interface in this particular instance is this one, because that's going to be our internal LAN interface, which everything is on. And so we go to DHCP, add. We know it's interface 1.2 because that's where we want it. Now we've got mode auto. So essentially, just to go through these, so enabled is it will give out an IP address anyway, although I should point out that whilst I was doing this with VMware Workstation, what actually happened was it was on enabled, but I'd forgotten to disable the DHCP server for the VMnet. So actually it didn't give out an IP address. Either that or Windows 10 grabbed it from VMware first. So enabled is it hands it out, disabled is, well, it is what it is, and auto is it enables a DHCP server as long as it doesn't detect another DHCP server on the same segment. So for sake of argument, we can go for enabled. Ping IP when allocating a new IP. Okay, so ping when allocating a new IP essentially does what it says on the tin. So it will, prior to allocating an IP, it will ping that IP. If it receives a reply, then it will just allocate the next IP in the pool. Lease, unlimited, and timeout. So you'd use timeout. I don't know why you'd use unlimited. Essentially, DHCP is all about mobility on and off a network, so I would imagine that you'd use timeout, and 1 day is pretty standard. Okay, so we want to add our pool. So now our IP address is 10.10.0. by default, for some obscure reason, I preserve the first 10 IP addresses for devices. So we'll start at 11 hyphen, and that's our starting address, and then our finishing address, so 100. So that is essentially going to allocate IP addresses from 11, inclusive of 11, all the way to 100. Okay, we can reserve addresses here, so you'd reserve that against a MAC address. So you'd say I want, I don't know, 10, 10, 0, 12 against this MAC address. So when this MAC address applies for a DHCP lease, you give it this address. We're not going to do that at the minute. Okay, so the inheritance source. This essentially, if you have another interface that is a DHCP client, you can inherit the settings that is received and pass it through. Okay, so the gateway, these are the options for DHCP. 10.0.1, because that's our gateway. 255, 255, 255.0, because this is a /24. Primary DNS, we're going to use our AD server, although it's now just got rid of that. Okay. Secondary, use good old Google. DNS suffix is local, and as you can see, we've got all the others here, so we can tell it what POP3 server to use, what SMTP server to use, Win servers, NTP. Here you can apply custom DHCP options. So if you was going to put this on a telephony network, you'd have your custom DHCP options there, and that's just simple. You just create what it is. So phone option 10, I believe, option code 10, and then the option value, and that's where, so you would say, okay, well, I need this to go there for the option 10. Okay, I know, essentially that's it pretty much. So we now commit that. That's nearly committed. We got a load of warnings there because of stuff I was doing earlier on, but essentially it's committed successfully. And then we've got an interface, the mode, probe the IP, the lease, the DNS it's going to hand out, so that's going to be the primary and that's going to be secondary, the gateway, which is the interface it uses to get off its network, and its DNS suffix. Also the IP pool information there. You can view the allocation here, and here's something that's quite interesting, as much as when I did this before, I've obviously got the lease there, so I'll show you how to clear that. But also here is the MAC address, so I would be able to use that to allocate an IP to this. So if I wanted this always to be 11, then I'd use that MAC address and allocate it there. Now, interestingly enough, to not do that, because that's the wrong one, interestingly enough, to clear it, to clear the DHCP lease, is done from the command line. So just give me a minute to log it in. So done from this mode, which is just the standard mode, it is clear DHCP lease, and then the interface, and it will know which interface it is because you've only got it on one interface. So you would you'd be able to select which interface you had there if you had multiple interfaces acting as multiple DHCP servers. The IP that you want to clear, in this particular instance it's .11, because that's what we've got as our lease, which is entirely the wrong IP address. Okay, so when we go back to there, we can see that that's been cleared. Okay, so coming back to our Windows box, we can renew that, and as you can see, it's picked up that IP there. If you do an IP config all, we get the primary DNS, secondary DNS. It knows it's more mode 44.local, so all is well, and we can in fact just browse to our heart's content, or possibly not. It has got DNS, just running a bit slow, which is fair enough, to this excellent website, Mode 44 Offensive and Defensive Security. The guy that runs it's a bit of a prat, but you know, you gotta bear with him. He does try. And there you go. So that's it. So that's DHCP server configured. That is working. We've now got access through. Let's just see if there's anything else. And so we can configure that. So there you go. So that's DHCP. We'll move on now to DNS Proxy, and what I think DNS Proxy would be a good fit for. And yeah, let's crack on. Okay, so DNS Proxy. What we're essentially doing here is we are configuring a DHCP server to hand out the firewall's IP address, its gateway, as the DNS server. Then all your clients will do a DNS lookup against the firewall address, and the firewall will then go off and do the DNS lookup and relay it. So this is really straightforward as well. I mean, with this you'd be able to control quite a lot how the DNS is done, and DNS is by far one of the largest attack vectors, essentially. Rogue DNS servers, people adding host files and things like this. There's a lot of reasons why you'd want to control your DNS and where it goes and where the firewall does its lookups, as well as where your clients do. Okay, so we're going to add a DNS proxy, which I'm going to call secure, even though technically speaking, I guess it is what it is. We're not inheriting it. Primary is going to be our AD server. Secondary is going to be good old Google. The interface is going to be on 1.2. That's where it's. That's where the DHCP server is, and that's where we're going to be receiving our DNS queries. DNS proxy rules. Essentially, you are adding here the name. So if you want to do a lookup against something else, against another DNS server for particular domains, you would add the domain there, and then your primary and secondary addresses there. Static entries are what they say they are. That's the name, the FQDN, fully qualified domain name, that you'd be looking up. So the Punisher .mode44.local, and then you would add the address in there of where it is. So if that was at 10.10.0.11, that's where you'd put it, and then you'd add that, and then that would be all good. Advanced TCP DNS lookups, max pending requests is what it says, is 64 maximum pending requests, because you don't want your DNS to lock up because you're not receiving replies in a timely manner. UDP, obviously fire and forget. Query retries, 2 seconds in between retries, 5 attempts. And cache, enable time to live for the cache. So you would get, say you get a DNS reply, it's cached it, and that DNS is then cached for, let's say, a day. During that day period, the firewall wouldn't go and look for another one, wouldn't look for another resolution for it. It would just hand out its cached resolution. There's pros and cons to all that, because you're gonna, if you have a higher TTL, you're going to decrease the amount of DNS traffic that's hitting your WAN and your internet connectivity. If it's too high, however, and you have a dynamic website, now especially with use of cloud and everything like this, it's admittedly a lot of that's done behind a CNAME, so you've not really got an issue, because then it's going to do a lookup on the other side. But if you had just a straight DNS mapping and it was a day, and they changed the IP address halfway through that day, you're not going to be able to get to it for the next 14 hours. 12 hours, sorry, 14 hours, wow. Because it won't do a lookup against it. Okay, so, okay. Right, so we now know where that is. We've got the primary DNS, secondary DNS, DNS server profile. Okay, so in DHCP now we need to alter our DHCP options, because we need to take out this. We need to take out this and make our gateway IP the IP for the primary DNS. I'm not going to change it for secondary. Now, by default, as mentioned in videos previously, the Palo will do, it'll attempt to get to its primary DNS server through its management port, because that's what it does. So we need to come into service route configuration, because we're not on there. If you see, we're actually sat off here, which is actually off ETH14. So DNS, source interface, ETH14, and then source address servers gateway. So it will just use the server's gateway, which is the interface address. So Ethernet 1.4, its interface address, its IP address is server's gateway, and that's the address it will use. Okay, right, commit that. Okay, that's committed. So now, assuming that I've done everything right, we'll go back to our Windows box, which you can see has no IP configuration apart from the good old PIPA address. We can renew it. That will then pick up, not through that it won't. That will then pick up the gateway of 10.10.01. You can see we have got DNS resolution, because this is how this thing works. Our IP address and so on. And so now we should just be able to go to website, just to get a random website as opposed to, so we know that we're having to take me to a useless website, click the button, and then we know that we're going to one that it's had to do a lookup for. Now for some reason today, oh there we go, some reason today everything's running slow, I don't know why, but as you can see it's done the resolution, it's found the website, and that's all good. Okay, so that, in a nutshell, is DNS Proxy. You've got DNS Proxy there. You're telling it where to go. It's using that as the gateway. all good. So now we'll configure NTP. I'm going to configure it using this Cisco router that we have here. Okay. So the first thing we need to do is get into configure mode, config T, which is configure terminal. Then we'll tell it to, and give it the authentication key. Key, a key number, type of key. We can now configure the passphrase, but on the Cisco we can put a single character if we want. On the Palo it only accepts 6 characters or more. So in a huge stroke of originality, I'm going to use Cisco NTP. Okay, we'll tell it that we want to authenticate NTP, and that the NTP trusted key is key 2 that we configured above, and that we want this router to be the master, and we're going to go for stratum 5. Essentially, the lower the stratum number, the more authoritative the NTP servers seem to be. So clocks will tend to synchronize with one that's, say, NTP stratum 1 as opposed to 5. Now what we want to do is we want to make sure that we don't trump any other more authoritative NTP servers, unless you wanted to completely limit your NTP to your own network and your own server, in which case you'd configure it as stratum 1, and then NTP clients wouldn't look anywhere else for NTP. Okay, so we'll just write that configuration. And then we can see the configuration there. So we've got the authentication key, which one it is, want to authenticate, trusted key 2, and that is completed. Okay, so onto the Palo now, and so this is the router we're using, and we're going to use this interface instead of the management interface, which it will do by default. So again, we're going to have to change the service routing configuration to go out here to use this one. Okay, so this is in device, and then setup, services, NTP. Our NTP server address is going to be the other side of this. So if we do a show in brief, see it's 172.16.02, and that is our Ethernet 1.2. If we come back here, 1.2, we can see is what links the external switch to the Palo. Okay, 172.16.02. We can use symmetric key. Key ID, they don't have to match between this and the other one, because the key ID is local to the box, so it knows what key it's using. So for instance, you'd have a key ID here, and then if you wanted to select symmetric key on there, you'd have a different key on there for a different secondary server. But for ease, I'm going to select 2. Our algorithm is MD5, and our key is Cisco NTP, and they match. Okay, so now as I said before, because by default the Palo uses the management interface for services, we have to tell it now that it wants to go there for its NTP. So in the same again, services, in the setup menu, service route configuration, been here before, NTP, use 1.4, which is, no, use 1.2, I'll get it right in a minute, there you go, 1.1, yay, and it will select by default the external address. If you wanted to use a different address on there, then you just have to set up a different address. and it would use it. Okay, okay, and that's the configuration done. So we'll just commit that now. And whilst that's committing, we will get the okay. So if we actually just look now, in fact, back to dashboard, close that. So it actually says NTP time is learnt. It knows that it's restarted the daemon because we configured it. Synchronization has been performed. Excuse me, some bit of coffee. And then if we want to confirm it further, we can SSH to our box. I don't know why it does that every single time. Okay, and show NTP, and then we can see that it is synced. NTP synced, yes, reachable authentication type, and the server that we're using. And if you had any issues, it would be in there. And that really is NTP. That's it done. So enjoy.